Now, you may have been told that this is machine language, but this is in fact assembly. The difference between machine language and assembly is that machine language is the same as binary. It can be run on a computer directly, while an assembly language is made up of arcane instructions that must be converted into machine code using software called an assembler. Now, while doing the research for the video, I became a bit confused. Like, we all know that machine language is binary, but in many cases it is shown as hexadecimal, which in fact is just for convenience, but machine language is binary, make no mistake. And if you want to claim to know machine language, just, learn binary. However, if the machine language is not low level enough for you, you can always go for microcode. Wait, no, that stuff is actually embedded. You cannot do anything in most cases. Microcode typically resides in a high-speed memory and translates machine instructions, state machine data, or other input into sequences of detailed circuit-level operations. The machine instructions are separated from the underlying electronics so that instructions can be designed and altered more freely. It also facilitates the building of complex multi-step instructions, while reducing the complexity of computer circuits. Writing microcode is often called microprogramming. Yeah, kind of obvious. And the microcode in a particular processor implementation is sometimes called a microprogram. Some hardware vendors, especially IBM or Lenovo, use the term microcode as a synonym for firmware. Firmware is stuff like BIOS. In that way, all code within a device is termed microcode, regardless of it being microcode or machine code. For example, hard disk drives are said to have their microcode updated, though they typically contain both microcode and firmware. The lowest layer in a computer's software stack is traditionally raw machine code instructions for the processor. In microcoded processors, fetching and decoding those instructions and executing them may be done by microcode. To avoid confusion, each microprogram-related element is differentiated by the micro prefix. So the microcode has its own set of micro-instructions, its own microassembler, its own microarchitecture, and I guess its own microprogrammer or something, made by dwarves. Now, a high-level programmer like yourself, or even an assembly language programmer, does not normally interact directly with microcode. Unlike machine code, which often retains some backward compatibility among different processors in a family, microcode only runs on exact electronic circuitry for which it was designed, as it is an inherent part of a particular processor design itself. It allows you to fix some issues like logical errors and bugs, since instruction sets were hardwired previously. Now, you don't really need to know assembly perfectly to use it as a tool. Nobody these days really codes in assembly since it's really time consuming, even though it is theoretically the fastest programming language. As someone once said, if you program in assembly, make sure you're paid on an hourly basis. If you're one of those people that can write assembly by hand and not lose your sanity, then you truly are a bloody legend and you get all of my respect. The rest of us will have to make use of Compiler Explorer. I think Visual Studio has a similar feature called disassembly, but the whole thing takes like 30 minutes to load and it's really not worth your time. To the right you can see the assembly generated for this relatively simple C program that performs a linear search through an array of integers. It is at least kind of manageable and readable, so you could imagine writing that by hand. But if you for some reason decide to switch the instruction set to something else, even by accident, you'll probably quickly regret it after seeing the nightmare. Just pick some other instruction set, I won't judge. You may think with everything laid bare you'd have more capabilities to go faster, but unfortunately it is actually pretty tough to write good, fast-performing assembly code by hand. That is unless you're one of the old C wizards or Michael Abrash, the god of optimization himself. In almost all the cases, you're better off writing just plain old C, C++, Rust, or Zig if you're feeling extra adventurous. Side note here, Zig won the Software Drag Racing Challenge, where the goal was to write fastest prime sieve, on channel Dave's Garage, hosted by former Microsoft engineer Dave Plummer. You can encounter assembly in the wild in the old video games of 90s or in the cheat engine. So actually knowing assembly and having basic knowledge of it is a good investment of your time if you're a gamer. In future videos we're gonna take a look at cheat engine and its guts. So stay tuned, like and subscribe.